Greetings again. Let's take a look at the parent function for cubed roots. Let's explore the parent function of the cubed root of x. To start off with finding our table of values, we're actually going to start in the middle of this table. If I was to plug in 0 for x, I would get 0 for y. I'm going to go to the positive direction, meaning my next value would be 1. If I plug in 1 for x, the cubed root of 1 is 1. Next, if I was to plug in 2 for x, 2 is not a perfect cubed. If I'm to look at my perfect cubed values, the next one would be 8. The cubed root of 8 gives me 2. Now, I left these top ones open because we also can take the cubed root of negative numbers. The cubed root of a negative 1 would give me a negative 1. The cubed root of a negative 8 would give me a negative 2. So those negative values matter in our table. We can see that it's very symmetrical. So let's graph those and see what it looks like. I have my point at my origin. I'd have negative 1, 1, and I'd have positive 1, 1. Then I'd have 8, positive 2, and negative 8, negative 2. Think of what a x cubed graph looks like. It's an S-curve. Well, this one is the cubed root, so it's almost like a sideways S. Extends beyond those points, it would keep going. For our domain and range, remember domain is x's, range is y's. Our domain value, our x's, are all reals. So instead of writing x is greater than or equal to, we're going to say all reals. Let's take a look at the y. The y values, they go forever down and forever up, just very slow sloping. It takes a long time, but it still is all real values. With our transformations for our graph, it's going to be just the same as the squared root function. The a value still represents our vertical stretch. Our h value still represents our horizontal shift. And our k value still represents our vertical shift. We're going to approach these questions the exact same way we did before. Let's start with this example. I'm going to start off with my parent function table. So remember, that was negative 8, negative 1, 0, 1, 8. And we ended up with a negative 2, negative 1, 0, 1, 2. The first number I want to take care of is that 2. That's our vertical stretch. So I'm going to take each of these and times them by 2. So our first table keeps our x values, and our y values now are negative 4, negative 2, 0, 2, and 4. The symmetry makes it very nice on these ones. Our next value, our horizontal shift, is positive 4. Remember, we do the opposite. So we're going to subtract 4 from the x's because it's our horizontal shift. So it affects our x values. Our next table then is negative 12, negative 4, negative 5, negative 2, negative 4, 0, negative 3, 2, and 4, 4. Our last value is negative 3. That's our vertical shift. Vertical, meaning it applies to our y values. We now have our final table. Negative 12, negative 7, negative 5, negative 5, negative 4, negative 3, negative 3, negative 1, and 4, 1. In this case, I have a 10 by 10 graph, so I can't graph that first point, but I can go to negative 5, negative 5, negative 4, negative 3, negative 3, negative 1, and 4, 1. Now, as you take a look at these, it's kind of hard to see where that sideways S goes. So remember where your origin point was. That will help you remember kind of that center point. And that center point's -4, -3. So we sort of curve up like a squared root function here, and then we go the opposite direction the other way. Our domain is our x values, our range is our y values. The nice thing about these cubed roots is it's all reals. There's no limits on how far this graph can go. Again, similar to our squared roots, with cubed roots we can use Desmos. But to get that cubed root function, when you use the keypad, if you go to Functions and the Miscellaneous button, you can see your n root. So this, when you click that button, you'll have to enter your index number of 3. Here I can double check my values to see that I'm comfortable with my solution. Let's take a look at another example and make note that this looks very similar to the squared root values that we used in the previous video. Remember, our cubed root parent function, if we plug in 1 for x, we get 1 for y. Excuse me, let's do the negatives first. If I plug in a -8, I end up with a -2, and then we go positive in the other direction. Let's start off with our first value, this negative out front. Think of that negative value as a -1. That is my vertical stretch. So I'm going to times each value by -1. Therefore, our first new table, keep our x values, and try to leave a little bit of space there. And our new y values are 2, 1, 0, -1, and -2. So it's almost like we just flipped it, which makes sense. We had a negative, which implies a flip. +2 is our horizontal shift. We always do the opposite. So instead of adding 2, we subtract 2. Now this time I'm going to try to jump ahead, because I already know that the vertical shift of the add 4 affects our y values. So I'm going to add 4 to the right side. Try to take care of 2 steps in one. This would lead me to my final points of -10, 6, -3, 5, -2, 4, -1, 3, and 6, 2. I'm going to make special note of where that origin value originally was. I'm going to start there when I graph my points. But -2, 4, that's my sort of center point, if I think about it that way. -3, 5, and -10, 6. If I go the other direction, -1, 3, and 6 and 2. So I can see that sort of S curve, which will help me with graphing. Again, domain and range, all reals. And let's take a look at checking our solution in Desmos. So here in Desmos, make sure you use that negative and the cube root function under the keyboard, under Functions Miscellaneous. Here I can see that how that negative affected my graph. It flipped it. And I can see I shifted left 2 and up 4. So I took that parent function, I just moved it left, up, and flipped it. Okay, let's take a look at one more example. Stick with it. Let's start off with our parent table. -8, -2, -1, -1, 0, 0, 1, 1, 8, 2. We're going to start off with our vertical stretch of 1/2. So I'm going to take my vertical values or my y values and times them by 1/2. This gives me my first new table. I'm going to keep my x values and leave a little bit of space. My y values are now -1, -0.5, 0, half, and 1. Very nice and symmetrical. Now I'm going to deal with this +3. Remember, we do the opposite. It's a horizontal shift, so I'm going to subtract 3 from all my x values. And again, I'm going to try to jump ahead here. Let's take care of our vertical shift too, which says take your vertical values and subtract 2 from all of them. This allows me to jump straight to my final table. -8 minus 3 gives me -11. I end up with a -4, a -3, a -2, and a 5. Let's take a look at our y values. Be careful here. We end up with a -3, a -0.5 minus a 2 is -2.5. If you choose to use decimal form, you can try that if you'd rather use your calculator. Also, you could find a common denominator. You could also think of it as money. If I have -0.5 $1 and I lost 2 more bucks, I'm at -2.5 bucks. We end up with a -2. 1/2 minus 2 is -1.5. And 1 minus 2 is -1. Let's graph those values. Now -11 is just off, but I'm going to try to include it. -11, -3, -4, -2.5, -3, -2, -2, -1.5, and 5, -1. Now I'm going to make note of where that origin or that center point was. This would be my center point, so it gives me an idea of how it should be symmetrical. Now this one's kind of a tight squeeze because of that vertical stretch. Because that vertical stretch was less than 1, it was 1/2, that really shrunk our graph. Take a look at your domain and range. Again, all reals. It goes forever left, forever right, forever up, forever down. Let's look at Desmos again. If I take a look by plugging in the 1/2, that really did shrink my graph. It made it a very tight squeeze. I can zoom in, of course, to check any additional values, or I can zoom out to see that it does go forever left, forever right. The up and down, you'll notice, it's very slow sloping, but it does continue to go up and down forever. In preparation for next class, you should have your squared root and cubed root notes done. You had the 2 videos that you watched. Next, reminder, we've got our test before break. Therefore, for a lot of you, that's going to be on Thursday, if not sooner. Take care of that before you leave. If you have any questions, let me know, or make sure you ask and take advantage of Saver Time. Let's start doing our best we can to prepare for that test, and we'll see you next time.